New.
Okay, never a lesson.
What?
Never a lesson. You never took singing lessons.
No.
A lot of people assume you did.
La.
Okay.
New. Okay.
What's this? Can I see with these? Where are they?
These are these fun glasses. We're doing so many projects with NeoPixel LEDs. I thought we'd get these fun glasses that I always think are a great way to make your LED project better. So like LED project, okay, kind of fun, kind of cool. But like, look at how much better it is when you've got these glasses.
Life looks better with these,
Everything
generally speaking.
looks cooler and better. So you can actually also use these for like, there's various physics projects you can do with these glasses as well, because they have like a diffraction grating. But what I think they're neat for is if you have, especially point sources like LEDs or NeoPixels, not good for like EL wire or like diffused silicone covered LEDs. But, these are like $1 and they just make your project shine a little brighter.
Okay. Next up, give the gift that keeps on grounding.
That's right. This is an anti-stat mat. I had a couple people asking why we didn't have as much ESD stuff. We have like, ESD, pliers and tweezers and whatnot. But this is an ESD mat, and we even test it with our power supply.
This is the mat that you're using it on.
I know. It's what is this? It's a mat.
Yeah.
So it's A4 size. So I don't know. It's like about a bit bigger than a piece of paper. So it's like about 15 by 9 inches or so.
Nice shade of green.
It's a green, so you can tell that's a standard color of ESD. It's got the kind of an anti-slip bottom, and then this kind of soft silicone anti-stat matte top. It's got a grounding connector here with a clip that's also a banana. So you would connect this to the earth ground of if you have like a power supply or a multimeter or your wall adapter, whatever. This is how you would ground it. It's not naturally grounded. I mean, it's anti-static, but you want to connect it to an earth ground. So you could clip it to a chassis or something, check around your workbench. It's got like a nice long springy connector. And then, it's about, I don't remember exactly what it is, but it's like 10 mega ohms from here to the other corner. So it's a little conductive, enough to dissipate static, but not conductive enough to, if you have something that's functioning, it's not going to affect it. Although if you have something that's capacitive touch can sometimes be sensitive to even higher resistances, like a couple mega ohms. You can't measure the resistance with a multimeter. I tried it first. You actually have to. So there'll be people who get this. If you're like, hey, how come it's, I checked with a multimeter and I couldn't read anything. Your multimeter is not sensitive enough. Instead, what you do is you measure it by putting your multimeter into microampere mode and then putting a voltage across this and then measuring the current draw. And that's how I kind of calculated it was a couple tens of mega ohms. But handy, not too big. You fold it up, put it away, bring it out when you need an anti-stat surface.
Okay. Next up, really excited about this. I used to work with Sony a million years ago, and to see their hardware in our Adafruit store is a dream come true.
Yay.
More so because it now runs CircuitPython. We wanted to wait until we got CircuitPython running. It's still, in beta for that, but we have all the Sony boards.
Yep. So this is the Sony Spresense. There's a main board. There's an extension board that kind of gives it that Arduino Uno-esque layout, and a camera board. And it has Arduino support. You can also use an RTOS, although I don't remember which one, that gives you the most power. And it also has CircuitPython support. CircuitPython doesn't have like camera support yet, but it does have basic functionality. It's a very powerful processor. They're really beautiful and they're very interesting. It's a dual core.
Yeah.
I think there's like a GPS module.
They're powerful.
That's the antenna, and a couple other things. I mean, of course, there's a camera. There's sensors. But it's really interesting. It's a very powerful chip, and it's very Sony-esque, right? I mean, obviously it's beautiful
like
and well designed.
Sony. Yeah.
Yeah.
And the cool thing is you can just get the different ones, the pieces, or you can Voltron it up and just get the pack that we have.
Yeah. The center kind of feather-looking thing. It's not feather, but it looks a little bit like the feather size. That's the main driver. And then the extension board and the camera are optional.
Yeah, so this is what you only need, but if you wanted to get this so it could have shields and other things with it, like SD card, get that, and then there's a camera.
Yeah.
But if you're looking just get all in one, we have that.
And we have a pack.
Okay.
Yep, that's the Spresense. By request, we had somebody who wanted to pick up a bunch of these Feather M0 Wi-Fi feathers, but with the headers attached. We now have that. This is one of our older feathers, but we did have a couple left over from our project, so we put them in stock. Basically, no soldering is required. You just plug it in, and you're feathering away.
Okay, and we are now out of beta for Circuit Playground Bluefruit.
Yeah. In fact, this shows the previous one. I'll show the new one. I'll show the differences. So we're out of alpha, so we did a slight redesign that you can see here. Here's what changed with the design. So if you look on the overhead, I'll point out things. So you can't really tell the difference because all code will work the same, but I did change the LEDs from 0805 to 0603, and the resistors that are connected to them are also much larger. They're 10K resistors. So even though these LEDs are fairly bright, they use a ton less power because they're very high brightness LEDs and they're physically smaller. We also added a transistor switch. This PFET switch is connected to the NeoPixel and sensor power. So you can turn off the power to the light sensor, the temperature sensor, the 10 NeoPixels. You can always turn off the speaker because it's always had a speaker enable. And you can turn off the microphone power as well. And by doing that, you can bring the quiescent power, like the power of the Circuit Playground Bluefruit, down to a couple, like maybe 100 microamperes. And that's including the on LED. So you can really drastically reduce the current usage for low power design, but you'll still have the accelerometer on, so you can like shake to have it activate or something. And then when you want to turn on the LEDs, you turn on and the LEDs activate. So definitely save a lot of power. It's for low power usage. Again, by default, the FET is activated, so all existing code will work. But if you want to be doing low power projects, get the new version that has the transistor here and the smaller LEDs, and you'll be able to put into low power mode. We also made a couple adjustments here to the antenna. Nordic gave us some suggestions on how to have a better antenna filter. So you'll just see a couple more components here. Again, it doesn't affect, in a couple parts, moved here and there. We made these larger, we made this crystal smaller, nothing, again, nothing that will affect you that you can even notice unless you're looking for it. But I'm glad we did the first revision so people got a chance to look at it. And now we have a more final version that I think will make a lot of people happy and do more.
And Dave wrote, Dave Stelz, who does great form support, and he's done great guides with us, shake and wake.
That's right. You can
shake and wake.
Shake it and wake it.
And it still looks great.
Yep. And it still fits in the case, and still, again, CircuitPython works the same, Arduino works the same.
Yep.
Mostly just physical changes.
Okay. Star of the show, besides the community and you, Lady Ada, is?
The LPS33 pressure sensor, now with STEMMA QT connectors. So it's a great match. This is an ST pressure sensor. And what's really neat about this is it's ported. So it's got like this little port you can see here.
Yeah.
So you can connect an O-ring, and you can connect like a gasket and then a tube to it. And the sensor is protected inside. It's got a gel coating, so it's protected against caustic and wet materials. So we're going to actually try making a sip and puff sensor out of this because it's a good quality sensor. It does pressure. You can see here as I put my finger over it, it changes the pressure it detects because I'm covering and pressing down a little bit to press the air in. There you go. And of course, you can do negative pressure, and it can do I2C or SPI. And because it can do I2C, we have it connected here. You see with a cable, so it just plugs right into the STM32F04 feather, and then you can daisy chain an OLED display. In this case, it's
handy.
Yeah, it's just every quarter of a second it prints out the pressure and temperature.
Yeah.
We have the LPS35 in the store already, but this one is the ported version. So if you're wondering what's the difference, this one has a port. Otherwise, the code is the same. So you're actually going to use the same library. And of course, it has these very handy plug-and-play connectors. So it's going to be very handy for people who want a ported pressure sensor from ST, really high-quality sensor with protection on the sensing element, so you can use it in a lot of different environments.
Okay, it uses STEMMA, which is compatible with Quick and Gravity and Grove and
Yep.
bunch of others.
And the STM32, it's plug and play, no soldering in this project at all,
That's
and
cool.
I'm instantly getting data out.
Okay.